Okay, for college algebra, the next video for 1.6, which is going to be equations with radicals. So what we're going to be doing is solving an equation that looks like this, where it has a radical in it. Here's going to be our steps. So solving a radical equation. The first thing we need to do is isolate the radical. That means we need to get the radical by itself on one side. Then we will put both sides inside parentheses and raise them to whatever power is in the index of the radical. If the equation still has a radical in it, we're going to have to go back to the first step. Then we would solve the resulting equation. Here's an important step. If the power was even, you have to check your solution by substituting into the original equation. If the power was odd that you raised it to, like you cubed both sides, then you're good and you don't need to go back and check it unless you want to check and make sure that your answer is right. But if you squared both sides, you have to do that. So let's go ahead and solve that equation. My first step is to isolate the radical. I am going to choose to add that square root to both sides because you know I like to have a positive, like as many positives as I can. So now I have x by itself on this side equals the square root of 15 minus 2x. Now that the radical is isolated, I'm going to put both sides of the equation inside parentheses. And then I have to raise both sides to the power in the index. Since this is a square root, I will square both sides. On the left side, I'm going to have x squared. On the right side, the square root and squaring are going to cancel each other out, and I'll just be left with 15 minus 2x. So now I have a quadratic equation. I can solve that by factoring or quadratic formula or completing the square. I'm going to need to move both of these terms over to the left side so that I have x squared plus 2x minus 15 equals 0. And then I would solve this. I'm just going to go ahead and factor it just quickly. It factors to x plus 5 times x minus 3, which gives me two potential solutions or proposed solutions. This one would be x plus 5 equals 0, so x equals negative 5. This one, x minus 3 equals 0, so x equals 3. Now these are proposed solutions. Since I squared both sides, I do have to go back and check those answers. So when I check, what I'm going to do is go to my original equation and replace all of the x's with each number, and I have to do this twice. So if x is negative 5, I would write negative 5 minus the square root of 15 minus 2 times negative 5. And I'm checking to see if that equals 0. So that'll be negative 5 minus. Negative 2 times negative 5 is positive 10. So 15 plus 10. 15 plus 10 is 25. So I get negative 5 minus the square root of 25 equals 0. And that is giving me negative 5 minus 5 equals 0. That's actually not true. Negative 10 does not equal 0. So I'm going to have to cross off that solution because x equals negative 5 doesn't work. So cross that off. Now let's check x equals 3. So I get 3 minus the square root of 15 minus 2 times 3 equals 0. So that's 3 minus the square root of 15 minus 6 And 15 minus 6 is 9. So I got 3 minus the square root of 9 equals 0. Square root of 9 is 3, so I have 3 minus 3 equals 0, which does work. So x equals 3 is the only solution to that equation. All right, this one looks more complicated. I wish I would have left myself more space. I think I can just like go off the edge over here. So to start with, remember I need to isolate that radical. So I'm going to move this x over to the right side and move the 6 over to the right side. So now I have the square root of x plus 5 equals 2x minus x is x, negative 1 plus 6 is plus 5. Well, that's weird. Square root of x plus 5 equals x plus 5. Well, now that my radical is isolated, my next step is put both sides inside parentheses and raise them to that power. So I got this side in parentheses, this side in parentheses. Since it's a square root, I will square both sides. On the left side, square root of x plus 5 squared just gives me x plus 5. On the right side, when I am asked to do x plus 5 squared, that means I have to take x plus 5 times x plus 5. And I'm going to box multiply that. So on the right side, I'm going to have x squared plus 10x's plus 25. Okay. Now that is a quadratic equation. So I'm either going to factor it, use a quadratic formula, complete the square. Whichever method I use, I know that it starts by getting it equal to 0. So I have x squared plus 9x plus 20 equals 0. That factors nicely. Box factor it over to the side. I'm just going to tell you how it factors. It factors to x plus 5 times x plus 4. And then I will set each of those equal to 0 to get my proposed solutions. X plus 5 equals 0 gives me x equals negative 5. X plus 4 equals 0 gives me x equals negative 4. And since I squared both sides, I do have to check those answers. So I am going to check x equals negative 5. I do that by replacing all the x's with negative 5's in the original equation. So that would be the square root of negative 5 plus 5 plus negative 5 minus 6 equals 2 times negative 5 minus 1. Then working through this, negative 5 plus 5 is 0. Square root of 0 is just 0. So that is going to go away. Then I have 0 plus negative 5, subtract 6, which would be negative 11 on the left side. On the right side, I have 2 times negative 5, which is negative 10, minus 1 gives me negative 11. Since those two sides match, that works. So x equals negative 5 is a valid solution. Let's check x equals negative 4. Same way. So replace all of the x's with negative 4's. So square root of negative 4 plus 5 plus negative 4 minus 6 equals 2 times negative 4 minus 1. Negative 4 plus 5 gives me the square root of 1 plus negative 4 minus 6. Square root of 1 is 1. 1 plus negative 4 minus 6 would be negative 3 minus 6, which is negative 9. On the right side, 2 times negative 4 is negative 8. And then I have minus 1. Negative 8 minus 1 is negative 9. And that also checks out. So this one actually has two solutions. X equals -5 and x equals -4 both worked. Now this guy. This guy is just kind of monstrous. So we're going to really hope that we don't have to do a whole lot of these questions on our homework because they just take a long time and there's a lot of room for mistakes. So we have to start by isolating a radical. There's two radicals, so it's just, we're going to have to do this one like twice. So I'll start by adding this square root of x plus 1 onto the right side. So I have the square root of 2x plus 3 equals 1 plus the square root of x plus 1. Okay. So I've isolated the radical. That's this step. Then put both sides inside parentheses and raise them to that power in the index. So I'm going to put this side in a parenthesis and this whole side over here in a parenthesis. Square the left, square the right. The left side is nice. It is super well behaved. It just gives me 2x plus 3. The right side is not so nice. We're going to have to FOIL that because it's squared. So I have 1 plus square root of x plus 1 times 1 plus square root of x plus 1. 1 times 1 is 1, of course. 1 times square root of x plus 1 is square root of x plus 1. And there's another one here, square root of x plus 1. And then square root of x plus 1 times square root of x plus 1 is going to be regular x plus 1. So coming out of this box, I have 1 plus x plus 1, which is going to be x plus 2. So I got x plus 2 plus, I have a square root of x plus 1 in this box. I have a square root of x plus 1 in this box, which gives me 2 of those square root of x plus 1s. So 2 square root of x plus 1. So that's where I have here. If the equation still has a radical, you have to go back to the first step. So I'm going to isolate the radical. So I'm going to subtract the x over to this side and subtract the 2 over to this side, which is going to give me x plus 1 equals, then I have 2 square root of x plus 1. Okay, if I isolate this radical, that means I'm going to have to divide everything by 2, and that's going to give me fractions. So instead, I'm going to show you a hack for how to square both sides if you have a number in front. Because honestly, that's my next step. I have to put both sides inside a set of parentheses and square it. So let's write a little, hopefully we got room somewhere. We'll put it down here. If you have a number in front of a square root with stuff inside the square root. If I have a number inside a square root with stuff inside the square root, and I square both sides, then what I'm going to do is square the number and replace the square root with a set of parentheses. So if I have number and then square root of stuff squared, then what I'm going to end up with is that number squared times the stuff that was in the radical now in parentheses. So this is a good strategy for us to keep in mind. So back to this. Now the right side is the easy side because I'm going to get to that one in a second. When I square the right side, all I have to do is square the number, which makes it a 4, take off the radical and replace it with parentheses. So 4 parenthesis x plus 1. Now the left side, I have to do x plus 1 times x plus 1. But I feel like we've done that somewhere recently. I don't know, maybe not. But anyway, that's going to have to be box multiplied. X plus 1, x plus 1. So if you don't believe me, there's the proof. It comes out to be x squared plus 2x plus 1. Okay. Next move. We still have to solve this. So I'm going to go ahead and distribute the 4. So I have x squared plus 2x plus 1 equals 4x plus 4. This is a quadratic equation, so I'm going to move my 4x and my plus 4 over to the left side. So I get x squared minus 2x minus 3 equals 0. This factors. If you box factor it, we get x minus 3 times x plus 1. And then if you set each of those parentheses equal to 0, we get 2 potential solutions, x equals 3 or x equals -1. So let's see if either or both or none of those proposed solutions actually works. I know I have to check this one because I squared both sides. So I'm going to need to check in the original equation, that guy. So check x equals 3. So I've got square root of 2 times 3 plus 3 minus square root of 3 plus 1. Does that equal 1? 2 times 3 is 6, and 6 plus 3 is 9. So square root of 9 minus 3 plus 1 is 4. Square root of 9 is 3. Square root of 4 is 2. And 3 minus 2 actually is 1. So x equals 3 works. Let's check x equals -1. We got square root of 2 times -1 plus 3 minus square root of -1 plus 1 equals 1. 2 times -1 is -2. -2 plus 3 is 1. So square root of 1 minus -1 plus 1 is 0. So square root of 1 minus square root of 0 equals 1. That is 1 minus 0 equals 1, so that one also works. So actually, both of those proposed solutions worked. Yay. Oh, goody, it's a cube root. You know why I'm excited about a cube root? Because it's not an even index, and I only have to check if my original, like when I raised my power, was even. So I'm still going to follow the same steps, though. I got to isolate the radical. So I will add the cube root of x to both sides. So now I have the cube root of 4x squared minus 4x plus 1 equals the cube root of x. Then I have to put both sides of the equation in parentheses and raise it to the power that's in the index. So this time I will be cubing. And when you cube a cube root, those two operations cancel each other out. So I have 4x squared minus 4x plus 1 equals cube root of x cubed cancels out, gives me x. And it's a quadratic equation, so I'll go ahead and subtract that x over and get 4x squared minus 5x plus 1 equals 0. Ooh, I'm going to have to think about this one, how to factor that. I need what multiplies to 4x squared but adds to -5. Let's see, 4x squared 1. Multiplies to 4x squared, adds to negative 5. So negative 4x, negative 1x. So that factors to 4x minus 1 times x minus 1. We set each of those equal to 0. 4x minus 1 equals 0. X minus 1 equals 0. Add that 1 over to both sides, gives me 4x equals 1. Divide both sides by 4, I get x equals 1/4. And of course this one, add 1, x equals 1. I do not have to check those because it was a cube root. So I'm just going to have those two answers, x equals 1/4 or 1. Now, when we have an equation with a rational exponent, so that's written like this, x to the 3/5 equals 27. That really means that we had a radical, but there's actually a quick workaround when you have an equation that has a rational exponent. All you're going to do when you have a rational exponent is raise each side to the reciprocal of the exponent. Be careful with signs. It says, as seen in 7b. So we're going to be careful with signs on this one. So an equation with radical exponents. Raise each side to the reciprocal of the exponent. So here I have x to the 3/5 equals 27. So I will raise both sides of this to the power of 5/3. The 3/5 power and the 5/3 power, remember when you raise a power to a power, you multiply the exponents. So if I take 3 over 5 times 5 over 3, that is going to give me 15 over 15, which is just 1. So the reason I raise this to the reciprocal power is because those two cancel each other out and just leave me x like that. And then I have 27 to the 5/3. The best way to handle that is to rewrite it in its radical form, which means that the denominator is the index of the radical. So that is going to go here. The numerator is going to be the power. So I'll put my 27 inside that radical. The index is 3 and the power is 5. I have to simplify that cube root of 27. What number times itself 3 times gives me 27? That number is 3. So I have 3 to the 5th power, which is going to give me 3 times 3 is 9, times 3 is 27, times 3 is 81. 81 times 3 is 243. And that is our answer. Okay. Let's see why we have to be careful with signs on this one. I'm intrigued. I have a rational exponent here. So I'm going to take x minus 4 to the 2/3 equals 16. I'm going to raise both sides to the reciprocal power. So 3/2, which gives me 3/2 power and the 2/3 power cancel out and leave me x minus 4 equals. And then remember I'm going to write that in its radical form. Index is 2, which means it's a square root. Put 16 inside there and then raise it to the power of 3. So I have x minus 4 equals, square root of 16 is 4, and then 4 cubed would be 64. So x minus 4 equals 64. Oh, I forgot the plus or minus. That's where that sign came from. Y'all, when I did the square root of 16, that should be plus or minus 4. So I should be getting x minus 4 equals 64 if it was positive 4, or x minus 4 equals negative 64 if it was negative 4. So then I get two possible answers, x equals 68 or x equals negative 60. I don't see a reason why we should have to check this because we didn't raise it to an even index. So I think we can just call this one good and have our two answers of 68 and negative 60. The next section we have is equations that are quadratic in form. And believe it or not, we have actually seen these already. We just called them U substitution. So we have factored by U substitution. What we're looking for in U substitution is that we would have the same item, but the exponents, one exponent is twice as big. So here I have x plus 1, but this exponent is 1/3, this exponent is 2/3. So what I want to do is take the one that's the smaller and let it be replaced with u, and take the one that's twice as big and let it be replaced with u squared. So then it becomes easier, u squared minus u minus 2, and then we can factor it. You could factor it, you could use quadratic formula, you can still use all the methods, but we're hoping that it's factorable. So this example is actually down here for us to do, and then we'll look at another one. So here we have x plus 1 to the 2/3 minus x plus 1 to the 1/3 minus 2 equals 0. So we have the same thing, x plus 1, x plus 1. This exponent 1/3 and this exponent 2/3. Since 2/3 is twice as big as 1/3, we're going to replace this with u squared. We're going to replace this with u. So u squared minus u minus 2 equals 0. So you want to keep in mind what you used for u. It was x plus 1 to the 1/3. And then we'll factor this. This factors to u minus 2 times u plus 1 equals 0, which then gives us two proposed solutions. U equals 2 on that one. U equals -1 on that one. But the story doesn't end there, because the next thing we have to do is take what we had replaced before, this x plus 1 to the 1/3, and we're going to write it instead of u. So I'm going to write x plus 1 to the 1/3 equals 2. And I'll do the same thing on this one. X plus 1 to the 1/3 equals -1. And now I have that type of equation that we just solved, where I have a rational exponent. So I'm actually going to raise both sides to the reciprocal of that exponent. So I'm going to take both sides here and raise them to the power of 3/1. Well, y'all, 3/1 is the same thing as 3. So basically I am cubing both sides. So on the left side, the 1/3 and the 3/1 cancel, and I get x plus 1 equals. On the right side, I do 2 times 2 times 2, so I get 8. Subtract 1 from both sides, and I get x equals 7. Do the same thing for my other proposed solution, so cube both sides on this side. I get x plus 1 again, but this time it equals -1 times -1 times -1, which is -1. Subtract 1 from both sides, and I get x equals -2. So those are the two solutions that I get from solving this equation by u substitution. X equals 7, x equals negative 2. There is this caution here. When using a substitution variable, don't forget the step that gives the solution in terms of the original variable. So I can't stop here when I got u equals 2. I have to go all the way to the end to get what x equals. So get another one. We'll do 2 more like this. Okay, so I see that I have x to the negative 1 and x to the negative 2. Since x to the negative 2 is twice as big, well, negative 2 is twice as big as negative 1, I am going to replace this one with u. U equals x to the negative 1. That means this one is going to be u squared. So when I rewrite this, it's going to be 6 that was already there, u squared, plus, I replace that with a u, equals 2. This is quadratic, so I'll subtract my 2 over. I get 6u squared plus u minus 2 equals 0. And then I can factor that. What multiplies to negative 12 but adds to 1. So I got 6u squared. Multiplies to negative 12, adds to 1 is 4u, negative 3u. So that is 3, 2, 2, negative 1. So 2u minus 1 times 3u plus 2 equals 0. Then setting each one of those equal to 0 gives me 2u equals 1. So u is 1/2, or 3u plus 2 equals 0, so 3u equals negative 2, or u equals negative 2/3. Now we're not done because I still have to go back and solve for x. My original replacement said u equals x to the negative 1. But remember that negative exponent means a reciprocal. So another way to write that would be u equals 1 over x. So I'm going to take u equals 1/2, and instead of writing u, I'm going to write 1 over x. So I'm going to go 1 over x equals 1/2. Oh my gosh, you guys, we can cross multiply this one. I know how much we love to do that. So this is a case that we actually can. 2 times 1, x times 1 gives me 2 equals x, and that is an answer. Then I'm going to do a similar thing for u equals negative 2/3. So instead of writing u equals negative 2/3, I'm going to write 1 over x equals negative 2/3. And I can cross multiply that one as well. So I get 3 times 1, which is 3, equals x times negative 2, negative 2x. Divide both sides by negative 2. I get x equals negative 3/2. So my 2 solutions for this equation are x equals 2, x equals negative 3/2. The spacing on this one, I left a lot of room. This is another quadratic in form. So I'm looking at my exponents. I see that one of them is twice as big as the other. I have x squared and I have x to the 4th. So the one that's the smaller one is going to be u. So u is going to be x squared, which makes this one my u squared. So I'm going to rewrite it as 12u squared minus 11u plus 2 equals 0. And then I'm going to factor. So I need to know what multiplies, let's see, let me write in there 12u squared, 2. What multiplies to 24u squared but adds to negative 11u. So negative 8u, negative 3u, 3u here, 4u here, negative 1, negative 2. So this factors to 3u minus 2 times 4u minus 1 equals 0. set each of those equal to 0 to solve for u. So 3u would be 2. So u would be 2/3. 4u minus 1 equals 0. So 4u would be 1. U would be 1/4. All right, we're not done though, because I have to go back and figure out what x is. Well, I know that u had gotten replaced with x squared. So instead of u equals 2/3, I'm now going to write x squared equals 2/3. Instead of u equals 1/4, I'm now write x squared equals 1/4. And then I have to solve each of those teeny tiny equations, which are best solved by square root method. So I will take the square root of both sides, which on the left side, this one gives me x. On the right side, it gives me plus or minus, because I took the square root of both sides. And that will be the square root of 2 over the square root of 3, which my math lab doesn't like you leaving. It wants you to rationalize. So I do that by multiplying by square root of 3 in the numerator and denominator, so that now I have x equals plus or minus. The numerator is the square root of 6, and the denominator is regular 3. So there's 2 answers. And then this one's going to be real similar. Take the square root of both sides. So I get x equals, and that will be plus or minus the square root of 1 over the square root of 4. Well, this actually works out way nicer than the 2/3. That's going to just give me x equals plus or minus square root of 1 is 1, square root of 4 is 2. So this equation had 4 solutions: plus or minus square root of 6 over 3, and plus or minus 1/2.